In this talk, we will talk about data model and how reference type in data model is incorporated. In specific, we will delve into the details of this model using StateObject provided by SwiftUI. A value type is a type whose value is copied when it is assigned to a variable or constant. Reference types, on the other hand, are not copied when they are assigned to a variable or constant. Rather than a copy, a reference to the same existing instance is used. Both value type and reference type can be used in data model. For example, a point can be represented as value type with x and y being part of the struct, and the line can be represented by a reference type which is having a reference to this point as value type. This is explained in the diagram here. Example of value types are string, enum, strict, and tuple. Reference types are class, actor, and closures. A value type are not guaranteed to have a stable location in memory. During the assignment to a variable, a value type is put at any location that the compiler sees fit, but a reference type has a stable location in memory. All references to same object point to exactly the same place. If the source of truth in data model is a value type, @state is used in view and assigned the corresponding value. And if the source of truth in data model is a reference type, @StateObject is used in view and assigned corresponding value, which complies with ObservableObject protocol. A user defines a view by providing the struct definition of it. Different such views make up this view hierarchy. This is a static blueprint and is used by SwiftUI framework to build up the view tree that is displayed on the screen at any given time. This view tree has different view objects, and the view objects in this view tree are given identifiers. As long as the view object exists in this view tree, when a view object is no longer required on the screen, it is deleted from the view tree. When a view object is inserted into this view tree, to the time when it is deleted from this view tree, constitute its lifetime, the lifetime of this view object. During this lifetime, the identifier given to the view object remains same. And during the lifetime of a view object, changes in the view inputs will not destroy the view object. It will only modify the view object with the updated inputs. The state object lifetime. When a view object is created, its state object is also created and initialized with the value that is given to it. When the view object is destroyed, the state object is also destroyed. In between, during the lifetime of the view object, the state object is retained and is not recreated at the time of changes in view inputs. The lifetime of the view defines the lifetime of its state object. A view could be using a expensive resource. In that case, we want to keep that alive only when the view is visible and not otherwise. An example of such a resource which is expensive is when images are downloaded from the internet. When the view is visible only during that time, it is good to use the connection from the pool if it is maintained. And once the view is no longer visible, it can leave the connection from the pool. If a view has conditional branch and body can be one thing or the other depending upon the condition, the compiler will create different view objects in the view tree when the condition is true and when it is false. For example, in the diagram here, my view is static blueprint of a conditional view that is defined by the programmer. When the condition is true, a view is created and the ID is given to it. And when the condition becomes false, the view is destroyed and the other view, which is view B, is created. The identifier will be different. And when the condition will become true again, the view A will be created, not with the same identifier, but a new and different identifier. If there is a need to change the value of state object when the input to the view is changed, it is possible to bind the identity of the view with the input that is supposed to be changed. This will make the identity of view change whenever the input is changed, and the state object is recreated and initialized again with the value that is specified by you. A source of truth which is of reference type in data model is defined as data model 2 here. This also complies with the observable object. This publishes a property called name. Whenever there is a change in this property, the view which is reading this property will be updated and re-rendered accordingly. A property which is not published and still changes will cause no re-rendering of the view which is reading this property. A state object in view is assigned a reference type which complying with ObservableObject protocol. This is similar to what state does with respect to a value type in data model. A state object can be shared by a view to its subviews. It can be shared directly from view to a child view, or it can be shared via passing it through the environment. to pass state object directly into a child view. Child view uses @ObservableObject to receive that passed in input. To pass a state object via environment, parent view uses the instance method .environment and modifies the environment. And the child view uses the property wrapper @EnvironmentObject to receive this value as input into the child view. Whenever the published property of the state object changes, the child views which are using that published property will also be re-rendered. Let's write some code and see how we can use state object in our data model. We'll build an app which is going to have a data model called line. The line will be having a name which is a published property, another name which is an unpublished property. It will have 2 points. One is indicating the starting point represented by x and y coordinates, and the other one is the other endpoint. It will also have isVisible property which is telling that the line is visible or not, which is again a published property. We will provide a toggle button in the child view to toggle the visibility. If the published property is changed in the view, its corresponding view is also re-rendered and updated with the changes. This is the new name. If the name which is not published is changed, there is no observation that is done in the view and no changes will be visible, and the view is not re-rendered with the updated changes. This is also new name too. If we will change the isVisible property, this will reflect and will update the parent view. We will also see how the state object is passed from the view to its child view, which is presenting this toggle button. We'll create the app named line. We'll create 2 new groups. One is views and another one is models. In the models, we'll create line as our model. In views, we'll create other 2 files. One is line view, other is visibility editor. In the model line, we'll create the reference, name it as line. We'll compile it with the prototype ObservableObject, and we'll give it the property names and make them published. One is name 1. We'll directly assign it some default value. Name, this is published version. This is the other name, and this is unpublished version. We'll also use our points. This is point 1. We'll give them some initial values, which is 10 and maybe 20. This is 40 and 50. This is unpublished version, and then we will also give it is visible or not, and let's give it to as our initial value. We'll give it an initializer, and this seems correct. Only thing is type is CG point. If we want to get a point, we'll write a function for that. Is first point if somebody is looking for, or the second point. If it is the first point, we will return the first point 1, else we are going to return the point 2. Now we'll create our view files. Now we'll start writing our line view. This will have our state object, and we'll name it as private so that it does not conflict with the members wise initializer of SwiftUI framework. So this is our model, and we will initialize it with our line and give it some points. Here what is happening is that state object is going to be created, and also it is initialized with the value that is specified. We'll write our body function here. We'll first print the published name of the line. Now we'll allow it to be changed here. We'll give it a rounded border and also disable the auto correction. Same thing we'll do with name too. Now we'll use 2 points and join them with a blue line. This is the first point, and then we'll add line to the second point. And if it is to be visible, we'll give it a blue stroke, hence it is transparent, hence the background color itself. Let's give it a line width of 2 so that it's somewhat visible. Also, now we will provide the visibility editor and pass the state object to the child view by putting it in the environment. To stand them different and separate from each other, let's put some dividers. And give it a color of green. We'll give it here and also here, and then here as well. Now we start writing our visibility editor. This is going to receive the environment object. We'll give it a toggle to change the property is visible. This is published property. We'll give it the binding because it's going to update and change the source of truth given to it by the parent from outside basically. We'll provide in our preview a sample environment object. Let's see how it looks in our line view. Let's toggle it. Yes, it is changing. We'll change our unpublished name and it's not updating, and we'll change our published version and it just gets updated. This looks good. We'll check our visibility. This is also publishing and the observation is seen. Changes in the data are reflected on the views which are reading and using that data in the data model. In this episode, we have seen how reference type can be used for a data model. We have coded program to see state object, environment object, and observable object, and also looked at how observation pattern is achieved in SwiftUI framework.